at the how to make some calculate how to calculate use Lussac law in calculation. So in this class today, we'll be looking at some few calculation involving Lussac. That is how to apply the Lussac laws. You know, Lussac stated that when gases react, they react in a simple ratio, in a volume which is in simple ratio with one another and to that of the product, provided the temperature and pressure remain constant. That is to say, if for each reaction involving gases, they are always in um, what, in simple ratio of their volume. So now the question we have here, actually this question will be in the description section of the this video, so that you can always look at it. So in this question, we say that the volume 50 cm cube of carbon 4, carbon 2 combined with oxygen, 50 cm cube of oxygen. We want us to calculate the whole thing happen at s.t.p. Calculate the volume of the residual gas after the sparking. Now what we do here is based on what the users was able to discover. He said that since it's a carbon 4 having carbon 2 combined with oxygen to give us carbon 4. So based on that, from this equation, we say that the ratio of their combination, this ratio of their combination means also that the volume is in simple ratio too with one another to that of the words products. The simple ratio, this ratio with one another. Based on this, with this information given to us, we will be able to calculate the volume of the residual gases and then the volume of everything required here. So we said that calculate the volume of the residual gases. Now we said from this we know that 2 cm cube of carbon 2 will combine with 1 cm cube of what? Oxygen. So 50 cm cube of what? Carbon 2 will then combine with 1 over 2 times 50 over 1. That will give us 25 cm cube of oxygen. That is what we combine. So in the 50 cm cube of oxygen, 25 cm cube of it will combine with this. That is to maintain the ratio of 2:1:2. So in that case, the remaining volume of oxygen that did not combine with volume of oxygen remaining, volume of oxygen remaining will then be 50 minus 25. What am I doing instead? Minus 25 will give us 25 cm cube. 25 cm cube, that is 25 cm cube. We have 25 cm cube of oxygen remaining. Then the next thing we're going to look at now is the volume of the product, which is carbon 4, which is also a gas. So the volume of carbon 4 produced will still be looking at the relationship. The relation with that is this here, 2:1:2. So it means that from here they will combine the volume of 2 cm cube of carbon 2 will then give us 2 cm cube of what? Carbon 4. That means 50 cm cube of carbon 2 will give us 2 over 2 times 50 over 1. That will give us what? 50 cm cube of what? Of carbon 4. That is 50 cm cube. Let's save it here. 50 cm cube. Now, they said that calculate the volume of the residual gases. The volume of the residual gases now will then be, since we have the remaining oxygen is 25, total residual gases will be volume of remaining oxygen remaining oxygen plus volume of carbon 4 produced. That is to say 25 plus 50, that will give us 75 cm cube. That's 75 cm cube of what? The residual gases. Now, the next one we're going to look at is what? Say that the next question said that 40 cm cube of hydrogen combined with 30 cm cube of oxygen to form steam. Calculate the volume of oxygen required for the combination and the volume of residual gases again. So here, what we have again, we need to get the balanced chemical equation. To get the balanced chemical equation, what we have will be, we're talking about hydrogen now. Hydrogen plus oxygen, that will give us steam, gas, and also gas. So, which means 2 cm cube, 1 cm cube, and 2 cm cube are going to get Lussac. So now the volume of oxygen required for this reaction, we have 30 cm cube of oxygen combining with this 40 cm cube. That is the 20 cm cube of hydrogen will give us 1 cm cube, will react with 1 cm cube of what? Oxygen. So 40 cm cube of hydrogen will then react with 40, 1 over 2 1 over 2 times 40, that will give us 20 cm cube of what? 20 cm cube of what? Oxygen. So now the remaining gas there, the remaining oxygen will be volume of remaining oxygen will then be 30 minus 20, that will give us 10. So that is to say, this 10 cm cube is part of the residual gases. This 10 cm cube of oxygen is part of the residual gases. Now the next thing we're going to do is to calculate the residual gas. The residual gas here will then be, our residual gas will be, from this chemical equation too, you can say that 40 cm cube of hydrogen will give us okay, from what we have already, let me take it the other way around so that it will be easy to grab. 2 cm cube of hydrogen will give us 2 cm cube of what? Steam. Then 40 cm cube of what? Hydrogen will give us 2 over 2 times 40 over 1. This will cancel, we have 40 cm cube of what? Steam. So the total residual gases here in this case, will then be, we have here is remaining 10 cm cube plus 40, that is total residual will be 40 plus 10, that will give us 50 cm cube. That is 50 cm cube of what? 50 cm cube of what? Of residual gases. That is what we have here. So the next thing we're going to do, we're going to look at one more question that will help us to digest the whole thing. So here the question said we have to calculate the volume of, say that 30 cm cube of sulphur 4 combined with 10 cm cube of oxygen at s.t.p. Calculate the volume of the remaining sulphur 4 oxide and the volume of residual gases. Now we are going to get the balanced chemical equation. In the balanced chemical equation, let's say the balanced chemical equation will be So this is the balanced chemical equation. In this case, if you look at this very well, you find out that like we have been doing in the past, this is 2 cm cube, according to get this as 1 cm cube, and then we have 2 cm cube. Now here we have 10 cm cube of oxygen combining with 30 cm cube of sulfur 4. So you say calculate the volume of remaining sulfur 4. So since we are looking for the we are asked to calculate the volume of remaining sulfur 4, which means sulfur 4 tends to be in excess. So that is to say we need to find out the volume of this sulfur 4 that will combine completely with 10 cm cube of oxygen. So what we are doing here is that we know that 1 cm cube of oxygen will combine with will give us equal to 2 cm cube of what? Sulfur 4. That is what it will combine with. Then 10 cm cube of the same oxygen will then be 2 over 1 times 10 over 1. That will give us 20 cm cube of what? I can say of sulfur 4 of sulfur 4 oxide. That means 10 cm cube will react to 20. Now the volume of the remaining sulfur 4 will then be what? 30 minus 20. That will give us 10 cm cube. So the next thing the question says we calculate the volume of the residual gases. Then at the end of this reaction, we find out that we have 20 cm cube of this sulfur. From our balanced chemical equation, it means that 20 cm cube of this, which will combine with 10 cm cube of oxygen, will give us 2 cm cube of what? Sulfur, tetrasulfur, sulfur 6 oxide. That's sulfur 6 oxide. So what we have here is, anyway, let's go back with we'll continue with oxygen. Since we have oxygen, we say that oxygen is what? 1 cm cube of oxygen will give us 2 cm cube of this. 1 cm cube of oxygen will give us 2 cm cube of what? Sulfur 6 oxide. 2 cm cube of sulfur 6 oxide. Then 10 cm cube. That's why I say we can consider with that so that it will be more easy to understand. So will give us 2 over 1 times 10 over 1. That will give us 2 times this will give us 20 cm cube of what? Sulfur 6 oxide. Sulfur 6 oxide. Now you can see in this case it's a bit different from what we've been doing in the past. That means we started from the one given to us to get the volume of sulfur 4 that will combine, and also from here we're able to get the volume of sulfur 6 oxide that will be produced. Now you can also go by this. Looking at this, you find out that since this is 20, it means that here will be 22 is to 2. That means 20 is to 20, and it's also rhyming with this. Thank you so much for being part of this class. We want you to share, like, and also subscribe if you have not subscribed. One thing about subscribing is just a way of encouraging us. And now, if you have any question to ask us, feel free to leave your questions in the comment section there. And like I said, these questions will appear in the description section of this video. Thank you so much for being part of this. Bye.